In this video, I will demonstrate how to use SPS software to conduct a correlation analysis. Our research question is there a significant relationship between the free and reduced lunch percentage and the percentage of students scoring at the exceeding level in math? So we're going to look at the statewide school district data set that we've received. And in looking at this research, our null hypothesis is there is no relationship between free and reduced lunch percentages and percentages of students scoring at the exceeding level in math. Of course, our alternative hypothesis is therefore there is a significant relationship between these variables. So to get started, first thing we need to do is run our assumption check so we know exactly which type of correlation we need to run. So first, we're going to look at normality, and to do so, we will run a histogram. So let's go to Analyze, Descriptive Statistics and Frequencies. Now here, we want to make sure that our data is, our variables are selected properly. So they're already here in our variable box, but if not, we'd grab FRL, free and reduced lunch, and math exceeds to represent those percentages of students who exceeded in math. Put those over in that right-hand variable spot. Then we go to charts. Here, we make sure we select histograms and show normal curve on histogram. Click continue, click OK. And then our output is generating, and here we go. So here with these histograms, as you can see, the free and reduced lunch, FRL, is actually pretty normally distributed, which is great. Now we go to the next histogram, math exceeds. That also looks fairly normally distributed. So there's one assumption met. On to our second assumption, which is linearity, and we will run a scatter plot to make sure that we've got that taken care of. So let's do that by clicking on Graphs, going to Chart Builder. All right, now see here, we've got our chart builder. We would normally grab the variables from the left and bring, well, first we would go down, below to Gallery, select Scatter Plot. Sometimes we need to drag that scatter plot from down here up into the center square. Then we can select our variables. We can drag over free and reduced lunch, which is already here on our y-axis, and then we would also go down and grab math exceeded and put that on our x-axis. So let's go ahead and click OK. And we await our data to run. So, and there's our scatter plot. Again, let's make this a bit bigger so we can see it. All right, our scatter plot looks pretty good. It definitely, if we were to draw a rectangle around this, the majority of the scores are fitting in there, so we do have the linearity. There is our second assumption met. Our third is, well, and let's also, just to be fair, let's click on that. We are going to make sure that we have our linear, our line of linear regression here. We click Add Fit Line for total, and that is automatically added there. Make sure that we select lineal. And we'll close that. All right, excellent. And hopefully we will be able to see this in the video where we actually can see. We have to close that. And of course, that didn't work out. Let's try that again. Okay. So we look at our scatter plot and we can see again linearity, but also our third assumption is homoscedasticity. That is such a hard word to say. Where basically we want to make sure that sort of in the mid-range here is where we see a wider, sort of fatter chunk of data. So that again tells us that that normality and that assumption has been made. So since we've met all three of our assumptions, this means that we get to run a Pearson's R analysis to determine correlation here. So we will do that by going up to the top of our screen here, selecting Analyze, and then we want to go to Correlate. and bivariate. Now here again, we're going to pull those variables from the left, put them over to the right. They are already there for us. We want to select Pearson's. We want to make sure that the button for two-tailed test is selected and check flag significant correlations. So let's go ahead and click OK and see how our data generates here. Excellent. Okay. So when we look at this correlations information, very telling here, under Pearson's correlation, this is telling us that that value is, which would be our R value, and that R equals negative 0.696. We can round that up to negative 0.70. Our Pearson's range is generally between a -1 and a 1. And since our score here is negative 70, if we were going to look at this on a number line, we know we would show a strong, because the closer you are to the -1 or the +1, the stronger the relationship. And since this is closer to that -1, we know it's a strong, but also a negative relationship. This indicates a statistically significant negative relationship between the variables. As it says here in correlations, our significance is less than 0.001, which is less than our alpha, which means that we will reject our null hypothesis and determine that there, in fact, is a significant relationship between these two variables. And we go down to this last section of Pearson correlations. It also confirms this information where it has negative and where our Pearson, and it's also color coded. That pink there corresponds with negative. So again, confirming that we know we've got a negative, strong yet negative relationship. So I will now report my findings in APA format. A Pearson correlation was conducted to examine the relationship between free and reduced lunch percentages and the percentage of students scoring at the exceeding level in math scores across school districts. The results show a Pearson correlation of R equals negative 0.70, with a significance of P being less than 0.001. This indicates a statistically significant negative relationship between poverty levels and math scores in these districts. Therefore, we reject the null hypothesis. The correlation strength is, in fact, strong, making it meaningful. Practically, this means that poverty increases in a district, that as poverty increases in a district, math scores tend to decrease substantially. This suggests that additional funding and intervention are necessary to assist these students. And that concludes this video.